Let's use this stoichiometry map to solve today's worksheet. The worksheet that looks like this. And notice that the answers are given. The answers are provided so that you can check if your work was done correctly. And let's just review that map again. Notice that on this side, we have the given. And on this other side, we have what we're looking for. So you use the information on this map to try to figure out what are the steps to be able to solve a problem like these. Let's take a look at question number 5. In question number 5, it says, how many, or dichlorine heptaoxide decomposes into chlorine and oxygen. How many grams of dichlorine heptaoxide are needed so that 275 liters of oxygen are produced? And so let's just examine what's happening in this question. We know that we are given 275 liters of oxygen. 275 liters of oxygen gas. This is our starting point. It's important to understand where are we starting from and what are we looking for. We're looking for how many grams of dichlorine heptaoxide. So this is what we're looking for, specifically grams. So we're starting with liters and we're looking for grams. So let's consult the map. If in fact we are starting with liters and we're looking for grams, what might be the 3 steps? Step 1, convert liters of gas to moles of that substance. Step 2, convert moles of that substance to moles of what you're looking for. And step 3, moles of what you're looking for to grams of what you're looking for using the molar mass of what you're looking for. And so let's begin. The given is 275 liters of of O2 gas. On the bottom, we place the units of work trying to cancel out. That's why we put liters of O2 on the bottom. And on the top of the conversion, we place moles of what we're looking for, of the given. In this case, O2. And realize that the moles and liters are related by the gas molar volume. 1 mole of oxygen gas is 22.4 liters of that gas. That's the GMV. And we're now able to cancel out the liters of O2, and we're left in this step with the moles of O2. And remember to multiply by the top and divide by the bottom. 275 multiplied by 1 divided by 22.4 gives us a 3-digit answer of 12.3 moles of O2. Step 1 completed. In the second step, we take 12.3 moles of O2, the answer from the previous step, and we convert from moles of O2, which we're going to put on the bottom so that we can cancel out those units, to moles of dichlorine heptaoxide. Why? Because that's what we're looking for. And we realize this is the mole ratio. And where do we get the mole ratio? The mole ratio comes from the coefficients of the balanced equation. 2 moles of dichlorine heptaoxide for every 7 moles of O2. See the 7 right here, and this 2 from right there. Moles of oxygen cancel out, and now this answer will be in moles of dichlorine heptanoxide. And using a calculator, 12.3 multiplied by 2 divided by 7 gives us a 3-digit answer of 3.51 moles of dichlorine heptanoxide. Step 2, complete. Let's take a look at the final step. Take that answer, 3.51 moles of Cl2O7, dichlorine heptanoxide, and we put moles of Cl2O7 on the bottom. Why? So that we can cancel those out. And on the top, we place grams of dichlorine heptanoxide. And whenever we're converting from moles to grams, we realize that we will need to calculate the molar mass. That's what this number will be. And so we do the molar mass of dichlorine heptanoxide, where there are 2 chlorines units and 7 units of oxygen. And we know that the molar mass of chlorine is 35 grams per mole, and the molar mass of oxygen is 16 grams per mole. This gives us 70 grams from chlorine and 112 grams from oxygen, a total of 182 grams per mole. 182 grams of dichlorine heptanoxide is 1 mole. That's the molar mass after all, which allows us to convert from moles, which we cancel out, and convert those to grams. And you would take 3.51 multiplied by 182 divided by 1, giving us 639 grams of Cl2O7 are needed. And that's the answer to number 5. And those are the steps. Again, if you're given liters, convert those to moles. Moles to moles of what you're looking for using the mole ratio. And finally, moles of what you're looking for to grams of what you're looking for. Let's try another problem. This time, problem number 3. In problem number 3, manganese 4 oxide reacts with hydrochloric acid to produce manganese 2 chloride, chlorine, and water. And the question is, how many grams of manganese 2 chloride are produced? And so, which one of these is manganese 2 chloride? It's this one. And so, that's what we're looking for. How many grams of this? And so it's important to understand what is our destination. What are we looking for? And what is given? We're given 8.46 grams of hydrochloric acid. This is hydrochloric acid. It's a reminder to make sure you memorize the formulas of the acids. We have 8.46 grams of hydrochloric acid. And so we're starting with grams, and we're looking for grams. So what are the steps for this kind of a conversion? If we're starting with grams, we convert to moles using the molar mass. Step 1. When we find the moles of that given, we can use the mole ratio in step 2 to convert from moles of that given to moles of what you're looking for. And if we're trying to find grams, then this is the 3rd step. Moles of what we're looking for to grams of what we're looking for. And so the map begins from here down to moles, moles to moles, then moles to grams. And it's already described to you in the worksheet. So the first step is to take grams of what you know to moles. So 8.46 grams of hydrochloric acid We put grams of hydrochloric acid on the bottom, so we can cancel it out. And moles of hydrochloric acid on the top, because that's what we're looking for in this step. And we realize to convert from grams to moles, we're going to need a molar mass. And that's fairly easy to calculate, because hydrogen, there's 1 unit. Chlorine, there's 1 unit. Hydrogen has a molar mass of 1 gram per mole. Chlorine is 35 grams per mole. 135, 36 grams per mole. 1 mole is 36 grams of HCl, or hydrochloric acid. Grams cancel out. We're left with moles of hydrochloric acid. Using a calculator, multiply the top, divide by the bottom. 8.46 multiplied by 1, divided by 36, gives us a 3-digit answer of 0.235 moles of hydrochloric acid. Step 1, complete. The next step, take that answer, 0.235 moles of hydrochloric acid, and we place moles of hydrochloric acid on the bottom this time. Why? So that we can cancel it out. And on the top, we place the moles of what we're looking for. In this case, we are looking for manganese 2 chloride. And now that we realize that this is a moles to moles conversion, use the mole ratio. That's right. The mole ratio, there is a 1 in front of this. That's the coefficient of manganese chloride. And there's a coefficient of 4 in front of hydrochloric acid. Moles of hydrochloric acid cancel out, and we're left with moles of manganese 2 chloride. And using a calculator, we find the answer is 0.0588 moles of manganese 2 chloride. That's 2.235 multiplied by 1 divided by 4. Step 2, complete. And the final step, we take that answer, 0.0588 moles of manganese 2 chloride, and paste moles of manganese 2 chloride on the bottom so we can cancel it out. And what are we looking for? We're looking for how many grams of manganese 2 chloride. And when we convert from moles to grams, just like in the previous problem, we need the molar mass of this substance. And it's MnCl2, manganese 2 chloride. There's 1 unit of manganese and 2 units of chlorine. Those are 35 each. Use your periodic table, and you know that manganese is 55 grams per mole. Chlorine contributes 70 grams per mole, and that's 125 grams per mole. 1 mole is 125 grams. That's why I insist that you say grams, so that you know that that number in the molar mass is the grams. And moles of manganese 2 chloride cancel out. And using a calculator, 0.0588 multiplied by 125 divided by 1 gives a 3-digit answer of 7.35 grams of manganese 2 chloride are produced. Step 3, complete. Again, we were able to start with grams. We started with grams, and we used the molar mass to convert that to moles. We took those moles and converted them to moles of what we're looking for, and then we used the molar mass to convert that to grams of what we're looking for. Continue to use this map so that you can solve the remainder of the questions in this worksheet. And remember that the answers are given so that you can check whether you did the work correctly.